All right, welcome to NOAA Live. My name is Grace Simpkins, and I'm going to be moderating today's webinar. This series is sponsored by NOAA's Regional Collaboration Network, which is spread across the country and helps connect people to all that NOAA does. It's also sponsored by Woods Hole Sea Grant, where I work, located at the Woods Hole Oceanographic Institution here on Cape Cod, Massachusetts. To find out about future webinars and to see any of the resources associated with this talk, please visit our Woods Hole Sea Grant education page, and you can just look for the NOAA Live website or follow us on Facebook. This is the 27th webinar in a series designed to help you get to know NOAA and some of our incredible experts during these months of school closures. Now, all of our speakers work for some part of NOAA. Those of you that have seen this before know that that stands for the National Oceanic and Atmospheric Administration. Today, it's my pleasure to be introducing you to Cindy Preller at NOAA's National Weather Service Pacific Tsunami Warning Center. While we'll be talking about NOAA's role in predicting and educating about tsunami, we want to recognize that we are coming to you from the traditional lands of Native communities who have substantial traditional and local knowledge and so much to share with us. We acknowledge that Cindy is coming to us from the lands and seas of the ancestral Hawaiian peoples, and we are hosting this webinar from the ancestral lands of the Mashpee Wampanoag tribe and the Wampanoag tribe of Gayhead-Aquina. If you want to know more about why we make an Indigenous land acknowledgement at the beginning of our talks, please visit our NOAA Live website to learn more. A few guidelines before I hand it over to Cindy. You're all muted because we have a lot of people on the line and we want to make sure we hear her. However, as you've already discovered, we have our question box. Please write questions throughout the talk. I'll be keeping track of them for Cindy or writing them down, and she'll be stopping every so often to answer a few. We might not get to all of your questions, but we'll try to get to as many of them as we can during the webinar. Now, enough of me talking, and you can see I'm ready because we are again in Hawaii, but I'm going to hand it over to Cindy because she has so many exciting things to share with us. So it's all yours.
Aloha, Grace. Thank you so much. First, we need to give you a little preview as to what NOAA does. Hopefully that's going. Okay. Alrighty, so as you can tell, NOAA is all about a lot of things besides just tsunami. In fact, tsunami is just a little teeny piece of what NOAA does. Okay, I work at the Pacific Tsunami Warning Center on the island of Oahu, and I've also worked at the National Tsunami Warning Center in Alaska, and the United States has 2 warning centers, so that's it. And we're going to talk about nature's warning signs today. But first, a little bit about me. Please call me Cindy, and I am from Colorado. And there I am when I was just a wee thing, about 8, 9 years old, and a dorky 12-year-old right there. I thought about having my little stick bebop all over the West, but now I'm in Hawaii, and I'm so happy to be here. So I'm really curious if you guys have any questions before we start.
All right. So does anyone have any questions that they want to ask? You know, I know probably one of our students that is usually on our webinars will ask this, so I'm going to just go ahead and get it started. So Cindy, what made you interested in working on tsunamis?
Well, I was always interested in rocks, and so that led me to the path of geology. But in 2004, the Indian Ocean tsunami happened, and that put the word tsunami into the global vocabulary. And the United States tsunami warning system expanded after that. So that was an excellent time for me to join NOAA. I was with the USGS before that.
And Luke's wondering if tsunami caused a lot of damage. And I know you're going to get to that, so you can feel free to say I'm going to get to that if you want when one of those questions comes in.
It's up there with one of the most damaging natural hazards. Absolutely. But,
and the last question I'll ask.
Go ahead. I was just going to say really quick, tsunamis are, you know, not all tsunamis are huge and horrible. Some can be quite small and not damaging at all, you know, so it's good to know that they have a scale, just like a tiny tornado isn't going to do much compared to those giant ones. It's the same for tsunami. Sorry, go ahead.
So I'm going to share with you, I don't want you to answer these questions because they're all questions you're going to get to, but I want folks to know that you are getting to them. So I'm going to just give you a series of questions to prep you so when you get there, you remember that somebody did ask that and that it will be covered. So Geeta's asking about the water retreating, and Cammie's asking about the biggest tsunami. Sachev is asking how tsunamis form, and Robert's asking, are there reasons for tsunamis? Are they random? Brian again asked, why does the water pull back? So I know that those are all things that you're going to get to. So I just want everyone to know that Cindy has all of that in her talk. So if your questions on those are not answered by the end, you can feel free to put them in again. But the one question I would like you to answer before you move on is, Aoife and Cullum have asked this, and Audrey and Amelia as well. What's your favorite part of your job?
This is my favorite part of my job, working with you, building relationships with emergency managers like firemen and policemen and the Coast Guard, you know, really helping the people that help the people. That's my favorite part of the job. But there's a lot of really cool things about my job. We have we really have our fingers on the pulse of the planet. We get to see every earthquake that happens, and that's pretty cool.
Great. Well, I know you have a lot to share with us, so I'm going to pause on the questions and let you go on. Thanks.
Okay. Sweet. Awesome. Welcome aboard, everybody. So I'm so glad you're here. All right. So first, what is a tsunami, right? What makes it different from a hurricane? And basically, this is pretty simple. A tsunami is just a disruption in the entire water column. In our case, the really big tsunamis are usually made from earthquakes that are under the ocean on the sea floor. And when that earthquake happens, it lifts up the entire water column of the ocean. And it's pretty similar to throwing a rock in a pond, or even just, you know, scooting back and forth in your bathtub. You're disrupting the entire water column of the basin. But when you think about how big the Pacific Basin is, that's a lot of water. So basically that is what a tsunami is, a disruption in the water column. Okay. It's caused by this wonderful phenomenon known as plate tectonics. And again, these are the usual causes of the big tsunamis. There's several causes of tsunamis, but this one in particular, these great earthquakes, magnitude 9 earthquakes, happen where the ocean plate is subducting underneath a continental plate. And as it goes down, where those two plates rub against each other, that's where we had these mega earthquakes. So I'm going to run you through very quickly several animations here, and we're basically going to go from start to finish. How the tsunami begins, and then how it travels and how it arrives. And then we'll wrap it all up into one picture, and you should wonder about that kitty there. I'm inserting a why is that kitty there. All right, here we go. So first we have subduction. The ocean plate is subducting under the continental plate, and it bends and it's under pressure, and it can only take it for so long before it releases, lifts the entire water column, and creates a wave. And then that wave propagates away from the center. And we have measured tsunamis at every tide gauge in the world, but they're not necessarily huge, 40 hours out. All right, next one. Another cause, a very common cause for tsunamis are landslides, and they're often underwater. And when the land pulls down the slope, it pulls the water down with it, creating a tsunami. And these are usually local tsunamis. They don't normally cross the entire ocean basin, but they can be very bad right there where the landslide happened. The other thing about landslide tsunamis, and just speaking of which, I know we had a question, the largest tsunami. Largest is an interesting term. The Indian Ocean tsunami in 2004 killed the most people, probably created the most damage, but the largest tsunami is a tsunami in a fjord in Alaska called Latoya Bay. And that tsunami created a splash that was 1,700 feet tall. So that's pretty insane. You can Google it, and there's some great photos. Okay, so we can't warn for landslides because they are so localized. We don't have enough instrumentation. So if there is a landslide tsunami near you, nature's warning signs will be your only clue of what to do. All right, once the tsunami is underway, it's out in the open ocean. It goes as fast as a jet out there, 500 to 700 miles an hour. But because the ocean's so deep, the tsunami itself isn't very tall. It's about as tall as a kitty. When it arrives, this is the simulation of the 1964 tsunami in Valdez. It can pull the water out, but not necessarily will it always pull the water out. When the water is pulled out, that's the trough of the tsunami, right? When you think of a wave, there's a peak and a trough. This is the trough of the tsunami arriving first. All right, now we're going to put the whole package together. Here's our earthquake pushing up the ocean floor. There's our tsunami being pushed up, and now it's propagating out to sea. And this is exaggerated because that looks taller than a kitty to me, but there have been times, especially locally near shore, Japan 2011 comes to mind, where there was a hump about that big. And here we are at a shoreline near you. The water is being pulled out because the trough is arriving first. When it's pulled out, it goes out really, really fast, fast enough to leave the fish behind flopping. But it can be 20 minutes before that tsunami arrives because a tsunami has an unbelievably large wavelength. So here it comes. And in this case, it's coming in really frothy and like a bore, but sometimes it can come in really subtly, like just a fast flood. And then of course, as it's coming in, it's slowed way down because the slope of the sea floor has shallowed. And so as it comes into shore, I used to tell the kids in Alaska, it's about as fast as a bear, which is faster than me, about 35 miles an hour. So all that energy out to sea is being compressed and then pushed ashore, which causes tremendous damage. All right, so how fast is a tsunami in the open ocean? Everybody knows. Here's a hint. It's as fast as a jet, right? 500 to 600 miles an hour. How about when it arrives on land, how fast is it? Here's a hint. About 35 miles an hour because we've got shallowing near the shoreline. All right, so what causes tsunamis? You already know at least two answers to this question. I'm going to play some animations that my awesome colleague Nathan has created, and I apologize to Nathan because I had to shorten them so we have plenty of time for your questions. So this one, oh, actually, Grace, I think we're going to have you launch this one. It's in my thing.
I can launch it if you want, or I thought you could launch it. It's up to you.
Well, let's see how it goes. sometimes there's a lag and there's just a lot of sparkles. So we'll see how it goes. But anyway, I shortened it. This animation, which is on our PTWC YouTube page, is an entire century of earthquakes, but I'm starting it in the late 50s because that's when they really get going. Whoops. Yeah, I'm gonna need you to launch it, sorry.
That's okay. So let me launch that. That's in our one of our videos, right?
Yeah, I'm not seeing it, sadly. Oh, yeah, I did.
Okay. So I would recommend just running it, just talking about what you've got there then, sorry.
Okay, that's all right. So I recommend everybody check out our YouTube channel and look at Nathan's awesome animation of all the great earthquakes. And it really demonstrates the plate boundaries, plate tectonics, and it shows that the great earthquakes happened in a fury during the 60s, but then it was quiet for 40 years, but there's a lot more earthquakes. And this is because we've become better scientists with better sensors. So I'm sorry you're missing that one. Please go check it out on our channel, though. It's very, very cool. All right. Now, this is a game, and we are going to be looking at the amount of earthquake energy that's released for some of the great earthquakes. And this is another animation from Dr. Becker. So first we start off with some small ones, that monster 5.8 in New England a few years ago. Now after Haiti in 1970, which did generate a tsunami, what about this circle? How big is this earthquake, do you think?
Okay, so we're looking for guesses, kids. So Cindy has shown you the strength of some of the earthquakes, and you can see the circles are labeled, right? So the next largest one was a 7.0 in Haiti, and then we go down to a 6.9 in California. But what she wants to know is, what is the magnitude of that large circle that's not yet labeled? We want you to guess. And so we've got Cammie is guessing that it's a 13.9. Rebecca is just saying that it's huge. We've got a guess of a 20. Joshua says 6.9. And Catherine says 9.5. Jackson thinks a 4. We've got a couple in the 8s. A lot of folks are putting in the 20s. Gita thinks it's a 9.8. Sophia thinks it's a 14. So we've got a lot of different guesses ranging, I would say, from 4 to, from 8 to 20.
Fabulous, I love that. That's great. So as we play this, I want you to be thinking this represents the amount of energy that an earthquake releases. And we'll have several circles after this. Keep guessing, but we aren't going to pause for those. All right, here it comes. Yeah, let's see, drum roll. Let's see who was right. All right, here we go. So do we have anybody that guessed 7.8? Isn't that crazy?
All right, I'm looking.
Go ahead.
We did not have any 7.8s. We did.
All right, look at these as they keep going. And Virginia just keeps getting smaller and smaller and smaller. And most of these that were near the seashore did create some sort of tsunami. Now, when you think about earthquake energy, a really big earthquake, like a 9.0, has enough energy in it to power our planet for 180 days. Isn't that insane? All right, there's that 9.0 for Japan, and then Sumatra, 9.1, Alaska, 9.2, and here's the largest earthquake we've ever measured. It's certainly not the largest earthquake possible. The logarithmic scale, there it is, Chile, 1960, 9.5. And by the way, you guys, that was today. 60 years ago today, this earthquake happened in Chile. That 9.5 earthquake has enough energy to power our planet for over 500 years. All right, here's another one of Nathan's animations. This is showing the 9.5 earthquake in Chile. when you think about these really, really big events, they shake for a super long time. So Chile is in South America on the west coast. Look down there, you'll see the rupture. See that red? Now that red line that's also orange and yellow is, if you look to the sidebar there, it's showing you what we are expecting the wave height to be locally. The tsunami is now propagating across the ocean. You can see the clocks going. We're 9 hours into it. One of the most important things this animation shows is that the tsunami is more than one wave. In fact, it's hundreds of waves. And when it encounters islands, you see that cool pattern, it's rippling back away from them. So they get very chaotic as they interact with land. There it is hitting Alaska, 19 hours in. And now it's about to hit Japan and Russia. And at this point, it may actually bounce off of those shorelines and head back across the ocean again. We saw that during the 2011 tsunami. You can find this and other awesome animations on our YouTube channel that Nathan has made. All righty, so that's a good point to take some questions if you want to.
Excellent. Yeah, we do. We've had some questions that have been coming in. So I'll go ahead and share. There were a couple of people, Kurt and Robert both asked, if you had a detonation underwater, could it cause a tsunami?
Sure, it would be small. It would be nothing compared to 1960 in Chile. But there have been tsunamis recorded, filmed from nuclear testing during the 1950s when they were dropping bombs in the ocean. Those caused local tsunamis, which affected the folks that lived on the nearby islands. But again, they're usually quite localized to the area. There's no way we could put a whole bunch of bombs down in the trench to try to trigger an earthquake that would, you know, help us mitigate tsunamis. Sadly, we're not there yet.
Thank you. And we have a really interesting question. Francesca is just wondering why we see these tsunamis in the Pacific, but not so much in the Mediterranean or the Atlantic.
Sure. Yeah, that was, I was going to demonstrate that with the earthquake video that hopefully you all will go check out. And it's because of plate tectonics. We have very active plate margins in the Pacific Ocean, whereas the Atlantic has a spreading center right down the middle that's very well behaved. But the Atlantic, other than near Puerto Rico and in the Caribbean, the Atlantic is lacking any subduction zones where that one plate goes underneath the other, right? So those great earthquake mechanisms just don't exist there. So I would be happy about that if I lived on the Atlantic seaboard.
So an interesting question from Vinny is, how do we measure a tsunami? And you've been giving us these measurements, maybe the distinction between the strength of a earthquake versus what you're measuring with a tsunami?
Mm-hmm. Sure. We measure the tsunami by watching tide gauges all around the planet. A tide gauge is just an instrument that's usually near the shoreline, but sometimes they're in river mouths, and they measure the height of the water. So if you live near the ocean, the tide goes up and down, and you'll see measurements based on high tide, low tide, that we use the same instruments to measure a tsunami. And then also we have these deep pressure buoys out in the middle of the ocean, and that's why I know it's only about as tall as a kitty, because those are out there feeling the pressure of the tsunami as it goes over the top, and it raises the sea level a little bit. So centimeters out in the open ocean can equal many feet on shore.
Great, thank you.
Yeah, we don't measure a tsunami's power. I mean, we observe that and we witness that, but it's so powerful that, you know, we don't have instrumentation that survives a tsunami in order to measure the power. So that's something we do afterwards. And I've had some scientists tell me it's equal to like 3.5 locomotive engines all at once type metaphor.
Great, thank you. You know, Jackson is wondering, have you ever been in a tsunami?
I have not, and I am grateful for that. I have witnessed several at work digitally, but no, I personally have not been in a tsunami.
Okay, last question before we let you move on, because I know you have so much more to share. But I think this is a great one. Is Juan is asking, are tsunami multiple waves or just one?
Right, great. That's what we were showing in that animation. Thank you for coming back around to that. Hey, many, many, many waves. And that's what gets a lot of people killed, because that first wave will arrive and then they think the event is over, because it can be like 20 minutes in between waves and people, think it's over and they'll go back out again. So yeah, no, many, many waves. It can last for hours to days. The Japanese tsunami was continuous for more than 3 days. So thank you for that. Many, many waves. Do not think after that first wave. And also the first wave is not necessarily the biggest. Sometimes it can be the 10th or the 50th. I mean, it really depends on how all the waves are interacting with each other.
Great. Well, lots of information about how a tsunami is generated and how we measure it. And I know you're going to, some people have been asking questions about how we might know when it's coming and what we can do. So I know that's what's coming up. So I'm going to let you continue on. Would you like to ask this question of the students, or do you want me to?
Go ahead, but also let's just let them do that in the chat and I'll keep rolling.
Awesome. So go ahead and chat with me. What will you feel when a tsunami is coming? What do you think you will feel when a tsunami is coming?
All right. So if you are near the earthquake, right, you will feel the earthquake and it'll be intense shaking. And in any earthquake, I don't care where you are, if you're in the middle of the continent or near the ocean, you need to drop, cover, and hold, right? Drop, get under a desk, get next to the couch, get away from the windows, cover your head, and hold on. But if you are near the ocean, and this is super important because these earthquakes, even a smaller earthquake like a magnitude 7, can trigger a local landslide. And sometimes those landslides are underwater, right? So you won't even see it or possibly hear it, but there it is, creating a tsunami quite near you. So when you're near the ocean, you're in an earthquake, and remember, they can shake for like 5 minutes or more. Drop, cover, hold, and then I want you to count to 20 of your favorite things. Now, that may not make any sense, so let's just pause for a second and everybody close their eyes and just think for a second, what is your favorite thing? Your very favorite thing. It could be your dog, it could be your bike, it could be soccer. My favorite thing is chocolate. So let's just together pretend we've been in a great big earthquake. We're dropping and covering and holding on. And now we're going to count. And I want everybody to count with me out loud at home or just to yourself 20 of your favorite things. Are you ready? 1 chocolate, 2 chocolate, 3 chocolate, 4 chocolate, 5 chocolate, 6 chocolate, 7 chocolate, 8 chocolate, 9 chocolate, 10 chocolate, 11 chocolate, 12 chocolate, 13 chocolate, 14 chocolate, 15 chocolate, 16 chocolate, 17 chocolate, 18 chocolate, 19 chocolate, 20 chocolate. Thank you for doing that with me. The reason we're doing that is social science has taught us that if you think of your very favorite thing, it actually automatically lowers your blood pressure. It helps you relax. It washes your brain with happy, good stuff. So if you're in a disaster, that's a really great way to not panic, right? And 20 seconds is roughly equivalent to the amount of shaking that a magnitude 7 earthquake would generate. So if you're next to the ocean, you count to 20, it's still shaking. I need you to run to high ground. I need you to evacuate at that point. And that can be super tricky because it's still shaking and stuff will be falling off the walls, water lines might be breaking, people might be freaking out. But because it was 20 seconds and you're next to the ocean, there might be a landslide tsunami. So you need to get to high ground immediately. So this is something to talk about with your families. It's really important to do when you're on vacation, to look where you might run to first. You can always go up a building. How high? Top floor. Go as high as you can because there'll be people behind you probably. But this one thing will save your life. So 20 seconds, magnitude 7. 30 seconds, magnitude 8. And if it knocks you on the ground and you can't get up, it's probably a 9. And I want you to go to high ground as soon as you can if that happens. Okay? All right, did you guys know that animals can sense earthquakes? Elephants have special pads in the bottom of their feet. They actually stomp and talk to other herds over 100 miles away. Catfish, there's sensors in their whiskers. A lot of Japanese people have tanks full of catfish because the catfish will sense the earthquake before we do. Now, we're only talking seconds, not hours, but you know, if animals start acting a little weird around you, pay attention to that. They might know something's coming. All right, good spot for questions.
All right, we have a couple of questions here. So let's see. We had a question, is there anything that you can build, Winnie asked this, like barriers or something to protect you against a tsunami?
Sure, and a lot of communities do that. Some communities have planted mangrove groves because their roots are so strong. Other communities like Hilo in Hawaii after 1946, maybe it was after 1960, they've gotten hit a couple of times, but they built a big barrier spit out there. It does not stop the tsunami. But what it can do is help break some of that energy. So its immediate arrival on shore is lessened a little. But yeah, other than that, you really can't stop these things. And the other thing is that's important to know is there is no tsunami season and they cannot be predicted. So when the earthquake happens, we hustle and get to work, but there's no, you know, we're coming into May and it's going to be tsunami season. No, we're not that fortunate yet. Okay, I'm gonna roll.
Okay, we have an interesting question from Victoria. What do you do if you're in the water and you don't have enough time to get out?
If you're in the water, like swimming or snorkeling, you should try to get out. If you are in a boat, you can go out deeper, depending on, you know, if you're paddling or if you're in a motorboat, but getting right in that immediacy, getting further out to sea can actually be a little safer where it's deeper. It's super chaotic in the near shore, but yeah, if you're just swimming in the water, unless you're really a super fast swimmer heading out to sea, you should try to get in if you can.
Great. Well, I'll hold on to the rest of the questions. I know you have even more to share with us. And I have to just do a shout out to River, who had asked in the chat if animals can sense the tsunami and the earthquake. So I knew it was coming. That's why I waited for you to answer that. But good job predicting that, River.
All right. So what will you see when a tsunami is coming? And again, please answer in the chat room. This really depends on if you're near the earthquake or not near the earthquake. For some people, if they haven't felt the earthquake, what they see will be their only warning sign, right? But if you're in the earthquake, you can connect one dot to the next and think that that's a possibility. So here we go. Here's some pictures of tsunamis as they're arriving. This is the Indian Ocean tsunami. This is Japan, 2011. But what about this? She's just standing in the shoreline there. She's visiting Thailand. That is actually a tsunami arriving. There she is. Just 30 seconds later, it's up to her knees. And you can see this crest over here. That's the actual tsunami. So they're not always the water being pulled out, and they're not always this big ferocious force. Sometimes they're just a fast flood. This is a photo of the tsunami in 1964 in Crescent City, California. And here's 2006, Crescent City, California. Doesn't look like much is happening there, does it? But the tsunami actually came in below the, it was colder than the water in the harbor. So it came in underneath and just pushed up from the bottom, and there's a rapid rise in sea level. This is our only sign that something's weird, is this bubble. And after that bubble appeared, all the docks broke. So if it feels weird, if it looks weird, it probably is. And that counts for everything you do in life. If it looks and feels weird, yeah. All right. So This is Indian Ocean, but what's significant about this is, of course, here's the tsunami, many, many waves, very, very dirty, full of mud and rocks and who knows what. But over here in the very next bay, it looks just fine. You know, so every beach is going to have its own experience with the tsunami. And that has to do with the shape of the harbor, the bathymetry underneath the water. How about this? This is a famous piece of art that is often depicted as a tsunami. Is this a tsunami? It is not a tsunami. But if you do a tsunami search on the internet, you will see this beautiful, beautiful piece of artwork. The waves are too close together. It's too gnarly. There's a boat in there. This is a storm. All right. So speaking of doing an internet search for tsunami, I did this just the other day. We're gonna guess to ourselves because we want to have more time for questions later, but we're just going to go through these. Is it or is it not a tsunami? So the first one, yes or no? No. Second one? No. How about that one? The third one, it is a tsunami in a sense. That's Japan, 2011. In actuality, the island had sunk from subduction, and so this is really just the water flooding in. But the water columns disturbed. So this is the beginning of a tsunami event. What about that? No. Next one? Nope. Next one, same as the first one. How about this one with the shark? Nope. Next one? That one we've already seen. Okay, second row. It's the aftermath of a tsunami, of course. All right, this next one, you guys should be pros by now. No. Another aftermath photo. Here's a giant whirlpool in Japan. That is definitely part of a tsunami. And this is no. And of course, the last one, no. I'm sure you know that by now. All right. So during a tsunami can be chaos. And of course, afterwards is quite the mess to clean up. All right. So just to review really quick, if it looks frothy, like a root beer float, or if the water recedes really fast, if it comes in like a fast flood, if you see something strange, weird water behavior, if the animals start running away, if there's wonky currents, all of those are nature's warning signs for tsunami. All right, I'm pausing for questions.
Okay, great. We have a few questions here. So Theo's asking, why do bubbles form in the tsunami wave?
Great, we're coming up on that, aren't we, Grace?
We are.
We are, so I'm gonna hold that one, but excellent. Thank you for thinking ahead for us.
Okay, so another question that Ellie asks, I think just thinking about those big walls of water, do we actually in some tsunamis get a huge wall of water? And is there a name for that wave other than tsunami, or is that just the term for it, regardless of whether there's a big wave or a small wave?
So I'm assuming she's talking about the big giant curl that everybody immediately associates as a tsunami. That can happen, but it's very rare that it happens. It normally comes in like a fast flood or bores up and gets frothy. So I guess the other name for that would be a bore. But the big, tall, towering wave that is not a tsunami, which is also not a tidal wave, by the way. A tidal wave is the wrong word for the word tsunami. Anyway, it can happen, super rare, but it has happened, yes.
So that leads me into the question I was going to ask from Michelle, and Kyle sort of get at it. What is the difference between a tidal wave and a tsunami?
Right, so the tide is caused by the moon, right? The moon's gravitational relationship with the earth, and it's pulling the ocean in a bulge, which creates this oscillation, tide. So it has everything to do with our planet Earth and our moon and the sun also, of course. A tsunami is created by an earthquake, has nothing to do with the moon. Or a tsunami is created by a landslide, still has nothing to do with the moon. The only planetary interaction that I can come up with that would create a tsunami is if an asteroid were to hit the ocean, that would create a tsunami for sure.
Thank you. And Lindy's wondering, why does the tsunami slow down when it gets to shore?
Right, that's a great question. Thank you. So out in the open ocean, it's very, very deep, and the tsunami is actually a super long wavelength. So when you think when you go to the ocean to play and surf, and you see the waves coming in from each curl to curl, that would be the peak of one to the peak of the other. And I don't know, it can be 30, 40, 50 feet apart, whatever. In a tsunami, it's miles apart, 60 miles apart between peaks. And so it is the entire ocean that's actually being affected by the tsunami energy. So when you have this cruising along in a deep level, and then it's just like putting your thumb over a garden hose. When you come up to shore and it shallows, it compresses it. So all that energy is being pushed and constrained, and that pushes the water up and makes it taller.
Great. All right. Well, I'm going to hold on to some of these questions. Oh, you know what? Actually, there's one more question because Felix is 5 years old, and he's just wondering if a tsunami does anything to the fish, and someone else had asked about sort of marine mammals. So as a tsunami is moving through the water, does it damage any of the marine life?
I think it can. There's a fabulous video, Google Tsunami 2004 divers. There's some divers that went out and took some footage. Well, they were just underwater taking footage, and the tsunami happened. And he said he got hit on the head by a fish. So I think in the near shore they get tossed around, but animals are pretty good. Most of them have probably left the scene just because it feels weird, right? But there's accounts of weird creatures being left on shore because when the tsunami pulls out, it pulls out so fast that it'll leave the fish behind flopping on the sand. So yeah, I think everything in the near shore of a tsunami is open to be tossed around a bit like a washing machine.
All right. Thank you. I'm going to hold on to the rest of the questions and let you move on, Cindy. Thank you so much.
Absolutely. Thank you. Here we go. All right. Again, everybody think to yourselves or hit the chat. What will you hear when a tsunami is coming? Grace and I are going to do a little experiment, which is what I usually do in the classroom. And it's a poem, but sometimes, especially if you aren't near the earthquake. So let's say you're here in Hawaii, you live here maybe, or you're here on vacation, and the earthquake happened in Japan or Alaska or Chile, but we don't here in Hawaii, so many miles away, we wouldn't feel the earthquake. What if you're camping out on the beach and maybe your phone doesn't work, you don't have cell service anyway? The sounds of a tsunami might be your only warning sign, and there are 4. So one of them, here we go, blowing bubbles. I've got my metal straw, by the way. So the blowing of bubbles happens when the tsunami pushing, all that pressure from the tsunami is pushing in, and the air between the sand grains is actually being released from the pressure of the tsunami coming. And those bubbles can be in the water, but you can have the sand right next to you start blowing bubbles. Another phenomena is the shaker one. I just have banana chips in the Tupperware, but this is the opposite when the tsunami is pulling out to sea, right? And when it pulls out to sea, it sucks all the water out from in between the sand grains with it, and the sand grains will actually just bonk into each other, and you'll hear like this shaker sound. I experienced this on the coast of Oregon once when there was an earthquake offshore. It was small, but I heard and felt the rocks underneath the sand clunk into each other. It's crazy. Another one is it could be a loud roar, right? Really loud roar. And to do that, we make thunder balloons, which Grace and her son have done. So it's exciting. And then the last one is silence. And this one's kind of creepy. So imagine that you're camping on the beach and the ocean is pounding like it always does. You just hear it constantly. What if that stops and you hear nothing? If that ever happens to you, please leave. Please go to high ground, because that means the water has pulled out and there's no longer any ocean there. All right, my great friends up in Fairbanks at the University of Alaska created a curriculum, and there's a sound poem. So we're going to go through it. Grace, are you guys ready?
We are ready. I'm turning on our video camera so you can see us. This is Robert, my loyal assistant, who's going to help with the sounds. Put it up close. We're ready.
All right. Thank you, Robert. Here we go. It's called a wave of sounds. Use your ears to listen. Sometimes you can hear a change in the way the ocean acts before a tsunami appears. Sometimes you can hear it before it reaches shore, a bubbling sound that a tsunami is in store. Awesome. Sometimes you can hear it before it reaches shore, a tsunami building up its strength with a thundering roar. Was that your balloon popping?
Regular, so these are thunder balloons, balloons with little pieces of Play-Doh inside them.
Right. Okay, let's try that again. A thundering roar. Those thunder balloons are awesome. I really hope you guys make them at home. All right, but here's our dead silence. Sometimes it's not what you can hear. This thing has no sound. It's an eerie silence on the shore where you often hear the surf pound. Use your ears to listen. Sometimes you can hear a change in the way the ocean acts before a tsunami appears. And if you just happen to be on the coast of Oregon, you might hear cows in the sky. A lot of communities on the coast of Oregon use that as their test siren. All right. Thank you, Robert, Grace. Well done. Oh, do we have any questions at this point?
We do have some questions. So Erica asks a really good question. Once you hear these phenomenons, how long do you have until the flooding starts?
If it's a landslide tsunami, something locally generated, the fastest a tsunami has ever arrived that we are aware of is 1.5 minutes, about 90 seconds.
Great, thank you.
Normally it's like 15 to 20 minutes.
And James raises a good point. You might also hear people yelling, tsunami! So that might be another sound that you can listen for. Derek, sorry, go ahead.
No, go ahead.
Derek asks, how strong is the pull? If the wave does recede, is it strong enough to like pull you in? Is it a really strong sort of suction if the wave were to recede, if it's the trough that arrives first?
I haven't heard anybody talk about being caught in that, but I know that it goes out really, really fast. And, if it's going out fast enough to leave the fish flopping on the ocean, I would think that you would be left flopping too. But it's a great question. I'm not sure.
And Don asks, is it possible to outrun a tsunami? So if you hear the warning sounds, is it possible to outrun one?
You should definitely try, right? Our old rule of thumb used to be how high and far would you go would be 100 feet above sea level and a mile inland. But then Indonesia inundated 3 miles and Japan inundated over 10 miles. But let's pretend you have 20 minutes instead of 1.5 minutes. And I know my daughter could run the mile in about 6 minutes. I don't even want to think how long it would take me to run the mile, but that's still, right? That can still get you away, so you should try. Don't get in the car, but you could easily get on your bike. You could get on your horse if your horse isn't gone. Stay away from bridges, stay away from rivers, get uphill or up a building, but you should try it for sure.
Great. And just one more question before we let you move on is we're just wondering, actually, I think this is Michael that asked it, is how did you, I know you told us how you got interested, but I think he's thinking about careers. How did you get your job working in this interesting field?
Right, 2004, Indonesia, the Indian Ocean tsunami happened and the tsunami warning system expanded. So they basically tripled in staff size if you include all the positions that were added. So I knew somebody that worked there and was just lucky enough in that timing. I mean, I hate to say lucky when so many people died, But if you wanted to plan on becoming a tsunami scientist or a tsunamiologist or a tsunamicist, because I don't think we have a name, there isn't even a degree in tsunami. So you can study a variety of things to join us. Oceanography, seismology, computer programming. We design all of our own software, take a lot of math, but mostly come meet me, send me an email, accept an internship, come volunteer, let me know, and I'll help you. I'll help you get there for sure.
Great. Well, that is a very generous offer. And I am going to encourage you, if you want to follow up with, and just ask any questions afterwards of Cindy, her email, you can find it on the NOAA Live website, or you can simply probably Google Cindy Preller and NOAA. But I'm going to hold on to the rest of the questions and encourage you to move on, because I know you have a few more fun things to share with us.
I do. I have the incredible story of Tilly, who did I hear we have some folks from the UK? That's great. Tilly is from the UK. And England doesn't get tsunamis, really. I think it could. There was a giant landslide in the North Sea once that may have lapped the shores of England, but they really don't have the hazard like the Pacific does. So anyway, Tilly was in Thailand, and she knew the warning signs and saved a lot of lives. So I've shortened this video. We have the link for the whole thing, and her story is just wonderful. So anyway, here we go. Oh, I want you to be thinking about what warning signs did Tilly notice? Oh, no. Oh, that's right. That's one I'm playing, isn't it? Here we go. Sorry, gang. And like I said, I shortened this. So I'm clumsy too. I'm not very good at this movie editing thing.
If you didn't know her, you'd think 10-year-old Tilly Smith was just an ordinary schoolgirl. She enjoys all the things ordinary schoolgirls do. She lives an ordinary life and goes to ordinary lessons here at Daneshill School in Oxshott in Surrey. But on the 26th of December 2004, Tilly Smith was caught up in an extraordinary situation and reacted like lightning to save the day. She and her family were on holiday in Phuket in Thailand when the Asian tsunami struck. Most people failed to spot the first warning signs in the water, but Tilly had just studied tsunamis in school.
I remembered because I had been taught it in the geography lesson, and it was the exact same froth, like you get on a beer. It was sort of sizzling.
Just 2 weeks earlier, Tilly's geography teacher, Andrew Carney, had taught them about the early warning signs for a tsunami and how important it is to act quickly.
From the time you suspect something's wrong, then it's crucial to get to higher ground and to get away from the seaside. Even if the water is not that high, the power of the waves could crush and drag you down and drag you away.
I said there's definitely going to be a tsunami, and my mum didn't believe me. She didn't react, and so she just kept on walking, and my dad sort of believed me, and Holly, my sister, was getting really scared, so she ran back to the pool, and then my dad went back with her, and then I said, right Mum, I'm definitely going, there is definitely going to be a tsunami, and she just, bye then. So I went back, and she was sort of reacting a bit more when I had gone, and so she went back to see if I was okay, and then the minute that she had come back, the water started coming up the beach.
But with such simple but crucial information, Tilly managed to save the lives of all the people on her beach.
Well, I told my dad, and my dad told the security guards, and the security guards told the people on the beach, because there was quite a few families on the beach, just in the water.
Some reports claimed Tilly saved over 100 lives that day, but she says the real hero is her geography teacher, who saved her life and those of her family.
If it wasn't for Mr. Carney, then I'd probably be dead, and so would my family, so I'm quite proud that he's taught me that in the time, that it was. My mum didn't realise, because she wasn't taught about tsunamis when she was younger, and she didn't realise what a tsunami was. She didn't even know that word existed. So I think it's really good to actually know the word and be taught it. Sort of felt guilty that I had survived and all those people hadn't. I'd like to go there again just to finish off our holiday, and I'm quite proud of myself that I knew what was happening.
So you are not unmuted, Cindy, just so you know, so we can't hear you. But while you unmute yourself, I just want to do a shout out to Bob, who wrote that he's a geography teacher in the UK, and he said that Tilly's story is well known. So well done showing that, Cindy. And I also had a few questions. So just to reiterate, if you go to the Woods Hole Sea Grant page, we have the NOAA Live site there. You can see the full Tilly video. If you could probably Google it and find it another way, but we've got the full video there, as well as if you want to watch it again through Cindy's webinar, that's where it will be posted, because we had a couple of questions about that. So Cindy, awesome. Sorry, you're unmuted, so I'll hand it back over to you.
Hey, I just want to wrap with this really fun summary of everything we've talked about, because I know our time is running. So let me pop this up really quick, and then yeah, I'll take whatever questions you want anytime. Okay. So I hit the movie. Can you see the video, Grace?
I cannot see the video, but if you want me to try to play it for you, I can.
Yeah, please do. I don't know why I'm hitting it, but it's not going. So yeah, if you could, that'd be great.
Okay.
Well, maybe it's because, oh, go ahead. There we go.
Let's put some basic information on the table. While more common in the Pacific, a tsunami can strike any coast, anytime. It's one of the most destructive forces in nature. A series of waves, usually caused by an undersea earthquake. These powerful, fast-rising floodwaters can smash everything in their path. Even small tsunamis can be dangerous, especially to swimmers, surfers, and boats in harbors. But there are ways you can prepare. First, understand the warnings. If an official warning is issued, do what it says. Just as important, pay attention to warnings Mother Nature provides. You may feel a strong or long earthquake. You may see the ocean suddenly rise or fall, or hear a loud roar. If you experience any of these, a tsunami could be coming. Protect yourself. Quickly move to high ground or inland away from the water. Stay out of the tsunami hazard zone until officials tell you it's safe. The first wave may not be the last or the largest. Dangerous currents are possible for several hours or days. Prepare yourself by doing a little homework. Think of the places where you spend your time and map out routes to safe places, high ground or inland, away from the water. Practice walking these routes so they become familiar. Be prepared and stay safe.
Great. All right.
All right. Thank you so much. Boy, that went fast.
It did go fast. And I just want to thank you so much for being a part of our NOAA Live series, for giving us such an excellent talk on tsunami and the warning signs and what we can do. Very, very informative. We are out of time to take any more questions, but you answered so many anyway. I know that our kids always have more questions. And so if you do, you can always email Cindy if you have any more questions, or like I always like to say, you can always also do a little research on your own. So thank you so much for being a part of our series and educating us. I want to just tell everyone we are not having a webinar on Monday. It's Memorial Day here in the US. And so we will be off for the day, but I did assign a little bit of homework if you want to do it. You can look on our NOAA Live website, but I encourage you to watch any old webinars. So go back and maybe watch one that you haven't watched before. You can make a drawing of your favorite webinar and send it to me. I would love to have some for our website. And we're also taking a vote. So our last webinar on June 12th will be an all-star webinar. So we want you to vote for your top 3 favorite webinars, and we'll see if we can get some of those speakers to come back as guest speakers. So please go on, please go on and vote for your top 3. We'll be listening to you to tell us what your favorites are. But next Wednesday, we'll be hearing about coastal marshland in my Texas backyard from Nikki Fitzgerald. So if I don't see you before then, I'll see you next Wednesday, same place, same time. Well, not the same time because we're leaving Hawaii and we're going back to 11 a.m. next week. So for those of you in Hawaii, I'm so sorry. I know that's super early your time. We've so loved being in your time zone, but we are going back to 11 a.m. on the East Coast. So we will see you either really early your time or mid-morning our time. Thanks, Cindy.
Thank you. Bye, everybody.